Hello everybody. What I'm doing now is I'm doing another presentation on exercise 3H, probably the more difficult type of questions that are in 3H, and maybe you can watch this and figure out how to complete 3H. Alright, so what we're going to do is to find the unknown angle theta in each of the triangles below. So here we have a triangle, a right angled triangle, with our reference angle here, and we want to know what theta is equal to. Could it be 40 degrees or 50 degrees or 30 degrees or whatever it is. Now, we're used to working out side lengths using trigonometry. Now we're going to use trigonometry the other way to figure out unknown angles. So from our reference here, from our reference angle, straight across from our reference angle is the opposite side. Right next to our reference angle is the adjacent side. And straight across from our right angle is the hypotenuse. Now, we know the hypotenuse, that's 7, and we know the opposite side, that's 4. So let's think what sine, cos or tan, which trigonometric formula involves the opposite and the hypotenuse. Well, hopefully you remember that sine of theta is equal to the opposite divided by the hypotenuse. Now we can put in some information here that we know. So we know sine of theta, and remember we don't know the reference angle, is equal to 4, because that's the opposite side, and 7, which is the hypotenuse. Okay, now let's see here. Now we need theta on its own. We need to undo this sign. Now I'm hoping most of you know that the opposite of plus is a minus, and the opposite of the times is a divide. And the opposite of a square is a square root. Well, the opposite of a sine is an inverse sine, and that's a sine with a little 1 up here. Now this will undo this and leave theta on its own. So if I do inverse sine to both sides, that'll keep my equation balanced. And what will happen is it'll undo that sine there and there. Those will cancel out and just leave the theta. Now I'll have inverse sine of 4/7. Now if you put that into your calculator, the inverse sine button usually happens when you press second on your calculator and then sine. Or sometimes it could be shift and then sine, depending on the type of calculator you have. And if you put in inverse sine of 4/7, you should find you get an answer 34.849. Now, if you say, well, okay, I need that to 2 decimal places, that'll round to 34.85. All right, hopefully that helps. On to our next example. Alrighty, find theta, so it's another one where we have to find how big this angle is here. Alrighty, so let's see, straight opposite our reference angle is the opposite side. Right next to our reference angle is the adjacent side. And straight opposite our right angle is the hypotenuse. Okay, the hypotenuse is always opposite the right angle. Now let's see, we know the hypotenuse and we know the adjacent side. Well, what trigonometric ratio, sine, cos or tan, involves the adjacent and the hypotenuse? Well, hopefully you remember that cos of theta will be equal to the adjacent over the hypotenuse. So cos of theta will be equal to 7/11. Now, we need to get rid of this cos so we get theta on its own. Well, the opposite of cos is inverse cos. So they're opposites. So this will undo this. So if I do inverse cos on both sides, they're opposite processes and will undo each other. And I've kept my equation balanced by doing inverse cos on both sides. So I've kept my equation balanced. Now, cos and inverse cos, they're opposites and will cancel out, and that will just leave theta. And that's the worst theta I've ever drawn. Okay, so inverse cos of 7/11. Now, to find inverse cos, it's usually second or Shift on your calculator, and then the cos button, and that will mean theta is equal to inverse cos of 7/11. Now if you put that in, you should find your calculator spits out the angle should be 50.4788. Now if we want to round to 2 decimal places, let's see, well, if we're rounding to 2 decimal places, this is closer to 50.48. Alrighty, so that should be your answer. One last one. Oh dear, you are horrid. You are horrid, aren't you? Just an absolute horror. Next question. Okay, what I want to do is to find theta, the unknown angle in this triangle here. Now, straight across from theta, straight opposite the reference angle is the opposite side. Right next to the reference angle is the adjacent side. And straight across from the right angle is the hypotenuse. Now, we know the opposite side here is 9. We know the adjacent side here is 13. What trigonometric ratio, sine or cos or tan, involves the opposite and the adjacent? Now hopefully you recognise that tan of theta is equal to the opposite divided by the adjacent. Alrighty, so tan of theta will be equal to 9/13. Now we need to get rid of this tan. Now the opposite of a tan is an inverse tan. Inverse tan will undo a tan. Now to keep the equation balanced, we've got to do an inverse tan on both sides. So tan and inverse tan, they're opposites, and will cancel out, and we'll leave theta on its own. So theta will be equal to inverse tan of 9/13. Now if you put that into your calculator, and the inverse tan button can be gotten by pressing second or shift on your calculator and then the tan button. Then you can put in 9 divided by 13. Now after you do that, you should find that the angle in question is 34.695. Now if we have to round that to 2 decimal places, it should be 34.70, because this will round up and it'll mean it'll be 30.70. Alrighty, well I hope that helps, and I'll see you in class. Oh, and remember, all this is related to exercise 3H. So now have a go at sum of 3H and see how many you can do.